Welcome everyone to the second webinar of our series on implementing targeted next-generation sequencing for detection of drug-resistant TB in high-burden countries, from recommendations to reality. I'm Wayne Van Gemmert from the Stop2B Partnership. This series is being organized by the Stop2B Partnership and FIND in collaboration with USAID, UNITAID, the Global Laboratory Initiative, and the New Diagnostics Working Group. Before I hand over to today's moderators, just a few points on logistics. As I just mentioned, this webinar is being recorded, and we will share the link afterwards, as well as the presentations. If you haven't seen it yet, there is an option for simultaneous interpretation into French if you click the globe icon at the bottom of the screen. And we encourage you to take advantage of the Q&A box. So please write your questions there and not in the chat box. I would like to now pass the microphone over to our co-moderators for today, Sarah Cook-Scalise and Smilka de Lusigny.
Hi, Wayne. Thanks so much for having us. Let me just get my video on. There we go. Good morning, good afternoon, good evening, everyone. My name is Sarah Cook-Scalise. I work with USAID Washington, based out of New York. We're really happy that everyone could join today. And on behalf of USAID, who is scaling up our investments in targeted next generation sequencing, we're really excited to hear more from the manufacturers today, as well as Anita from FIND. And I'll pass it over to my colleague, Smilka. Thanks.
Thanks, Sarah, and thanks, Wayne, for convening us today together with FIND and the partners. And it's really a pleasure to be here and co-chair this with Sarah as well. It's almost surreal to be at this point, especially knowing the path that we had to go through to get to having the recommendation that was published earlier this year, and really now being able to concretely talk with the private sector and manufacturers about their solutions and think through how these solutions can be applied in countries that we work in. So we are very proud to have been a part of that journey as UNITAID in partnership with FIND and of course with a broader partnership with Stop TB Partnership and USAID. And I'm very pleased to also co-chair this, learn more about the technologies, but also concretely understand how these technologies can be introduced in countries and in an affordable and acceptable way. Thank you. Sarah, over to you.
Wonderful. Thanks, Smilka. So for those of us who joined us last time, you heard during the first webinar about the WHO recommendations on targeted next generation sequencing. And today we're going to go deeper into the performance and characteristics of the specific WHO recommended assays. A lot of efforts have already been made and are continuing to further improve the performance of these assays so that they are more sensitive for detecting resistance to key drugs, including new and repurposed drugs. You'll also hear today from the manufacturers of the 3 WHO recommended assays about their very specific product lines, and each one are distinctly different. Without further ado, I'll introduce the first speaker, Dr. Anita Suresh, who is the head of the Genomics and Sequencing Unit at FIND. She will speak on tNGS assay performance and improvements in line with the updated WHO catalog of mutations. Over to you, Anita. Thanks.
Thank you, Sarah. Thank you, Smilka, and thanks, Wayne. Excited that we are in the second
Alexa, good morning.
Of the series. I hope you're able to hear me okay. So as the introduction said, I think my goal here is to be able to set a foundation or baseline, really, to be able to have the presentation sent by the companies, which is obviously the most exciting part of this webinar series today. But I think that what I want to set the stage is go through some of the common elements of sequencing workflows, and also talk about what they are, how they're distinguished, basically what makes them, what determines their performance, and also what are some potential opportunities for improvement of performance over the course of things that are ongoing in development and also coming very soon. All right, so just as we said, I think the main one thing we always emphasize is that with targeted sequencing, it's a workflow, not a single one module product. It is an end-to-end solution, really starting from the sample, in this case, a sputum sample, going through extraction, going through the amplification of the library preparation, and then the sequencing itself, followed by the data analysis and the results reporting. The three manufacturers, of course, the combinations we'll be presenting to you today. It's just so all of them have various combinations of products that make up this end-to-end tNGS workflow. Now, the big part of what obviously determines the results is about predicting the resistance from mutations. So the calls that are being made to say what is the resistance or the resistance to this drug versus another drug. The reason we can obviously do this as fundamentally is because there is such a strong correlation in MTB between the phenotype and the genotype, or you can essentially predict resistance knowing the genotype or the sequence. But there is how much we know today and how much potentially we can get to know over the course of many years, over time, as new drugs are rolled out, as new drug regimens are out in the field, and unfortunately, as new resistance emerges. So the Global Mutations Catalog published by WHO is the reference list in a way for these companies when we find or other people that did the evaluation, including the evaluations done for Shengting, but as well as for Nanopore and the Genoscreen and Illumina solution. But of course, manufacturers are free and have included additional targets beyond that was captured in the Mutations Catalog version 1. This could be based on literature reviews, based on in-house TB knowledge. So again, just reflecting back on the policy statement, the guidelines that were issued in March 2024 were really this very exciting because it was a class-based recommendation for the use of targeted sequencing for TRTB diagnosis, and 3 products that were specifically evaluated, or the data was evaluated for 3 products and reviewed, and the decision was made. And you will see that the recommendation was really on a drug-by-drug basis for looking at each product. And that's, I think, the crux of this discussion, right? Essentially saying, what is then the difference for sequencing? All of these companies, all of these products cover a lot of targets, and you'll hear about the specific targets from the different presentations. But it's about what met the performance criteria or not in this evaluation based on the knowledge that was known. So as I said, the version 1 catalog was the basis for, at least we know for a couple of the companies that was used as a list of reference. But they, of course, when they knew more, what they wanted to add more targets, they were free to obviously have their own targets as their commercial solution, commercial product. The sort of progress that has happened since the version 1 of the catalog obviously has been a second edition of the catalog. The whole idea was the initial catalog was the very first, the largest collection of data sets of TB, genotypic, phenotypic, correlated data sets in the world. 38,000 data sets over 40 countries. But that obviously still didn't cover a lot, especially for the newer drugs. There wasn't enough resistance information or studies, data generated from studies that existed to be able to do much more there. So thereafter, by the time this was released, we had already started working on a second version of the catalog. And this resulted this was also late last year. This was an additional 15,000 isolates that were included and really enriched for coverage, both from a geographic and a drug perspective. So the catalog, the second edition, definitely had targets for bedaquiline, for laminate, for clofazimine, in addition to all the targets that are already in there, the rest of the drugs that have been more commonly in use. So of course, we can imagine predominant is not yet there. So there's a version 3 that has started, is in development already, that has begun with the same expert group in WHO. Now, the reason I'm speaking to some of this, again, details that we probably mentioned before, is really on talking about what does this mean in terms of performance. So these, yes, there's updated mutations list, there's new targets and so on. So why is it important? Why does it matter to us? Because companies, in a way, or these products can actually be improved based on if they can update their products based on these targets, based on these additional targets that are in these mutations list. So where, for example, a product did not meet the criteria in terms of sensitivity, in terms of performance, where the sensitivity was low for a certain drug target, it was clear that sequence data was actually generated for these targets. So So that in turn implies that performance will improve as long as there's an added calls that are there. So there is some sequencing happening, but the calls are not happening, which means as long as I have but my bioinformatics pipeline tells me to say, hey, this particular thing that you're seeing, this mutation is associated with this resistance, so make that call of R for this drug. So the reason now I'll show you just this as a snapshot, of course, this does not do justice to the entire catalog. So please pardon me for any of the catalog experts or people that worked on the catalog that I'm showing along the call. This is just a very, very tiny snapshot. But what I want to emphasize here is that basically you're seeing that improvement, the difference between the two catalogs, just the sheer volume of what having basically statistically having another 15,000 isolates and really enriching, making sure there's enough coverage for all of these new drugs, what that leads to. So you can see for linezolid, definitely an improvement in sensitivity, still at a 50%. This is just based on the catalog. Compared to phenotypic. For clofazimine, you see it went from nothing because we had no data on clofazimine, it went to 78%. And for bedaquiline, again, no data in version 1 catalog, it went to 74%. So again, this is just based on, again, data sets. There's potentially additional mutations that we are not yet known in the world, or we don't have enough frequency of occurrence that we actually were able to capture in the data set and confidently say it's associated with resistance. So this essentially means you're already seeing that increase in sensitivity for bedaquiline and clofazimine. So now you can imagine any product, any assay that actually already has these targets in the wet lab piece of it, in the chemistry, in the amplification and primers, they will be, as long as the gene regions were covered, they will just need to make sure they are calling for the targets associated with these drugs in their bioinformatics pipeline and reporting. So in the cases, of course, for drugs, you may ask, what about linezolid? Obviously, it's still only at a 50%. A predominant, which is not yet covered, which obviously there is probably not that much data sets in the world yet, which is a good thing. We don't want resistance emerging for these new drugs so quickly. But this doesn't exist today. But I think performance, essentially, the idea is based on this, using the same logic, essentially, as knowledge of mutations associated with resistance expands, it's likely that performance can also improve as long as these assays are able to then reflect these targets in their, either in their bioinformatics or in the case of new targets or new gene targets that aren't covered, it is likely for predominant, for example, there could be targets that aren't part of any of what they aren't shared with any of the other current targets, the current targets associated with the other drugs. They may require some wet lab changes. So this means obviously they may need to add some additional primers to cover some genes or regions so that they are covered, so that they are able to then also cover them in the sequencing, their sequence information generated, and then there is a reporting based on the bioinformatics software of these calls. So essentially to say that rather than when you think of an assay like a PCR assay or other assays, you do have to go back to the drawing board to be able to create, if you want to change targets, if you want to update something, if you want to make a new version of the product with replace some targets. Difference here with the sequencing assay is you could pretty much do it in a couple of months if you had to just update the bioinformatics. Say we have to update the wet lab as well. It's a few more months than just that, but it certainly does not require going back to the drawing board, but really a revalidation with that entire, maybe starting from that place of the library prep, essentially the amplification, library prep, and so on. So really that wet lab comparison. So again, now this is the sort of the last slide here, but really to talk about what these expected improvements, because that was sort of the focus of this talk, of this base foundation talk in this session. Essentially, what are those expected improvements? So we said the first one, as long as if there are assays, companies that know that their assays are covering these targets, but they don't have them, they're not calling them, they're not reporting on them yet because they're essentially just using the WHO mutations catalog as the list of truth. Here's a way for them to update their data analytics and reporting, and based on this knowledge as their knowledge, and in a way the knowledge in the world improves of drug resistance associated mutations. This means you can do a quick reanalysis in silico to essentially check the performance and hopefully see that improved performance for these drug targets based on this updated pipeline. I'm going to do a sneak preview of some data that we have, for example, from really as an example of this for an ONT will be presenting later, but really from an Oxford Nanopore assay that was also one of the tests recommended in the GTG review. Essentially, you saw in that first, the original one, these were targets they did not have recommendation against, or performance. It did not meet the performance for bedaquiline and clofazimine. But you see that with their revised pipeline, which is essentially revised based on looking at the second edition of the catalog, this dramatic increase in sensitivity from 5.9 to 69.4 for bedaquiline, nearly from no reported targets for clofazimine to a 66.7% sensitivity against the reference. So that's just to illustrate sort of the potential and the ability to improve performance just based on that knowledge of mutations associated with resistance that then the assay manufacturers can quickly update, be it just from a bioinformatics perspective or a wet lab perspective when that becomes necessary. There's obviously even more future in terms of the AI for predictive analytics. I know there are groups that have started working on this already, but I think at this point it's not quite as many millions of data sets as needed to require AI. It's still manageable based on the amount of data and the calls going out. But it is something potentially we could utilize to actually have a sustainable way to keep track as new drugs and new regimens are rolled out. How do we make sure concurrently you also have development of diagnostics with the targets that are needed to ensure a rollout and it's actually sustainable use of new therapies. Now, I just spoke about the performance aspect. There's obviously all of the other aspects in terms of how do we improve the ease of use of the workflow, how do we shorten the time, how do we reduce the hands-on time, and how we increase automation and so on. So there's a number of options, number of things in development, I would say, or some products that are out there or things that are out there that can be in a way that still need to be validated for TB. So one example being that increased level of automation. So as you see, it is a workflow, multiple steps, so definitely hands-on. It's hands-on everywhere. But there are solutions, for example, from Clear Labs that actually take in all of these, including extraction if necessary, but definitely the amplification, library prep, the sequencing itself, all the way to generating a report. So really being able to have them on board. So those are just some options. Obviously, there's costs associated with automation, but there is that trade-off of whether you have that high throughput enough and you have the requirement for these standardized workflows in your lab. This is definitely, there are options like this that are coming on the market. There's the whole process of DNA extraction and the processing itself. So again, that is going to be a crucial element. Obviously, what goes in, you don't want to be spending time and money sequencing if you're not sure if you're getting the highest quality and what amount of DNA that you need. So that extraction is always a crucial bit when it comes to any sequencing assay, as it is for any molecular assay. So there's work on the way in terms of at least a quick search on NIH grants, talks about different solutions or different products that are in development, looking at improving these. So be it just the extraction processing itself, or even combining the extraction and library prep, or really reducing the number of steps for a library preparation itself. So this is just more of a quick highlight of the potential, the ways that are improvement. And really, we're not talking 10 years time, we're talking really in the near term, midterm, but there is work ongoing. So with the NIH grant timeline, you can think in 3 to 5 years, these could very predictably can actually be part of real products itself. So that's where I'll stop. Now you can hear the real deal from the manufacturers. We talk all the potential and some of the actual improvements, but I'll hand over back to my moderators and that. Thank you.
This was great, Anita. Thank you so much. So much work actually went into it, and very impressive to see how those updates of the catalog actually are impactful also on the technologies, and maybe we can unpack that as well when we start seeing the presentations from the three manufacturers that will be presenting. So we're shifting to that part of the webinar, which is really about the portfolios of products. So looking into assay characteristics, instrument models, procurement information, and we have three we are happy actually to have online the manufacturers of the 3 WHO recommended tNGS assays, and they will share with you information about their assays and the instruments they work with, as well as possible access considerations and procurement information around their products. I would like to introduce first the speakers of the presentation that is coming up, which will be a joint presentation from Genoscreen and Illumina. Genoscreen is the manufacturer of the diplex mixed TB assay. Dr. Nelly Badalato is the Research and Development Department Manager at Genoscreen. And we also have online Kelly Hoon, who is the Director of Global Marketing and Product Management, Infectious Disease and Microbiology at Illumina. So over to you, Nelly and Kelly. Thank you.
Thank you very much. Thank you. I thank the organizers to give us the opportunity to present our kit, Diplex MIG-TB, the first of its kind kit, THS kit for extensive culture-free prediction of TB drug resistance. So at Genoscreen, we designed and developed the first tNGS-based assay in 2014 for fast and comprehensive diagnostic of TB drug resistance. The first use in real life condition was in 2016, followed by its application in a WHO supervised drug resistance survey in 2017. We obtained the CE mark in 2019 for its use in routine clinical diagnosis. From 2019 to 2022, the assay performances were evaluated during the FIND Second Treat study. The results led to the WHO recommendation in 2023 and the complete guidelines published 2 months ago. We are now ready to bring this assay to the next level worldwide, especially in countries that need it the most. So Diplex MIG-TB is recommended as a reflex test following the diagnosis of TB or rifampicin-resistant TB. The assay significantly shortens the time to results by using a culture-free approach directly on clinical specimens, delivering results within 24 to 48 hours. It also provides extensive drug resistance detection covering 15 anti-TB drugs. The assay is part of a flexible and streamlined workflow. It begins with DNA extraction directly from sputum specimens or either from cultured isolates. These steps is followed by simultaneous amplification of multiple gene targets in a one-step PCR. Next, libraries of amplicons from multiple samples at the same time are prepared using Illumina reagents and sequenced on an Illumina platform, the most accurate technology on the market. The throughput is flexible, allowing for the sequencing from 4 to 384 tests per run, depending on the platform used. Finally, the sequencing data are uploaded to a secure web application that performs a fully automated analysis. The assay covers 15 anti-TB drugs, including group A and B drugs, and is the only rapid test available for detection of XDR-TB. Additionally, it simultaneously identifies mycobacteria, either for TB diagnosis confirmation or non-tuberculous mycobacteria identification, and performs also MTB genotyping. Following data analysis, key results are readily available and easy to interpret. a resistotype with a red and green color code is used to indicate resistance or susceptibility for all 15 drugs. For more information, a second level of results is available for each drug. The diplex map here displays Mycobacteria identification and TB strain genotyping alongside detecting mutation in all gene targets. With the diplex MIC-TB assay, web app, data analysis is made easy. With just few clicks, data are uploaded and analyzed, and within an hour, results are accessible, regardless of the number of samples. The key results, Mycobacteria identification and the resistotypes, are displayed on the dashboard. For each sample, including the diplex map and mutation information, are available for further exploration. With the web application, updates of the mutation catalog for interpreting the mutation is very easy and does not demand any action from our users. All results can be exported in different formats, including a summary report in plain language. Diplex MIC-TB stands out for its practicality, with its use for drug-resistant TB diagnosis and surveillance, including MDR outbreaks and research. And this is demonstrated by over 20 peer-reviewed publications from supranational reference laboratories and TB specialized hospitals. Following the WHO evaluation, diplex MIC-TB is the only test meeting class-based performance criteria for all 10 anti-TB drugs evaluated. During this study, the demonstrated overall sensitivity and specificity was above 95% for all priority drugs. A great achievement we have all seen this year is the release of the complete guidelines from WHO for the use of tNGS for rapid diagnostic of drug-resistant TB. Diplex MIC-TB is found to be accurate, cost-effective, depending on the context, acceptable and implementable under routine conditions. 2 years ago, the WHO recommended a new treatment regimen for MDR patients, the BPALM, including bedaquiline, pretomanid, linezolid, and moxifloxacin. Thus, we extended the drug panel in a new kit, the diplex TB XL, to cover all new drugs. Additionally, we improved the limit of detection to increase the performances on possibacillary samples, and we also simplified the overall workflow. The robustness of the diplex engineering allowed us to develop kits for other challenging pathogens. So we designed, developed, and brought to market the most performant and commercially available tNGS-based assay for drug-resistant TB diagnosis. To bring this assay to the next level, Genoscreen and Illumina have partnered. Together, we built a combo kit comprising the diplex MIC-TB assay and Illumina sequencing reagents to enable worldwide access with a simplified supply chain, with this common goal to help advance the WHO strategy to end TB. I will now pass over to Kelly from Illumina to further exemplify this partnership.
Good morning, good afternoon, good evening. Thank you, Nelly, for that great introduction and details around the diplex MIC-TB assay and the power of targeted NGS. I'm trying to get my share screen on here for a second. Okay, can you see my screen okay? Silence is golden. I'll assume yes. Okay, so thank you again. Thank
Sorry,
you all.
Kelly, we can
Yes.
see the text.
Okay. Whoops.
Kelly, I think you might have frozen on your video as well. If everyone could just hold for one moment, it looks like we're experiencing some technical difficulties, but we'll get things back on track. In the meantime, just to let folks know, we appreciate the questions coming in. Please continue to write questions via the Q&A box, and we will answer as many as we can at the end of the presentations. Anything that we don't have time to cover today, we will send out via written answers along with the follow-up after the webinar. So sit tight, please continue to ask questions, and we should be back on track in no time at all. Thanks. Kelly, it looks like we've got you back on board there. You're on mute though now, so there.
Apologies.
Excellent.
My
No
system
worries.
logged me out of what was going on here, so apologies.
Oh, great.
Can you hear me now though, Sarah?
Yes, thanks, Kelly. Go right ahead.
Let me see if I can share my screen again. Share screen. As many times as you do this and crazy, it's still. Okay.
We're still on presentation mode. There we go. Okay, excellent. Thanks.
Okay. Apologies again. So again, thank you to Stop TB and Fine for the opportunity to present today, and to Nellie for giving us an overview of the duplex MIC-TB. I really just wanted to set the stage on who is Illumina and how do we partner with Genoscreen to provide this best-in-class solution. Our mission at Illumina is really to improve human health and unlock the power of the genome. Our sequencers enable researchers in the academic and government and commercial settings for comprehensive understanding of the genome and how it translates into human health and disease. Our technologies really empower the healthcare providers to leverage genomics insights into clinical care and provide patients with diagnosis and groundbreaking therapies. I'm proud to share that Illumina just celebrated our 25th anniversary this past year. For those of you new to the technology, Illumina is a global genomics and human health leader, innovating the future of precision health. We develop DNA sequencing and array-based life science technologies to enable boundless research, discovery, and personalized health. Our technologies empower and continue to innovate towards the positive and impactful people and planet healing solutions. And for those of you interested in fun facts, Illumina is financially sound, has almost 10,000 employees, headquartered in San Diego, California. And as I mentioned, having just celebrated our 25-year anniversary, we're founded in 1998. Today, we have technologies that answer a diverse set of questions to help every person understand their unique blueprint, what diseases they may be predisposed to, or to help their body respond to treatment, and how to identify the right treatment for infectious diseases or even create a new treatment if needed. Our commitment to develop technologies that will more every element of sequencing and advance human health. As we think more about infectious diseases, though, and applications with Illumina's technology, we start with pathogen identification and drug resistance characterization. And that's what we're really here to discuss today. But this technology is capable of much more. Insights into clinical test development, such as case with the first published SARS-CoV-2 sequence. And that data was then used to create diagnostic assays and even vaccines. Pathogen monitoring and genomic surveillance, continued monitoring to improve and to understand our current treatments and preventatives, and if preventatives are still effective. And helping to support drug and vaccine development, host genetics and immune response. Biologically, not everyone has the same response to the same pathogen, and understanding how and why can help further the development in vaccines and therapeutics. The images here represent our portfolio today in running multiple applications or analytes. Think of these systems as genetics readers, and really they only vary by the number of samples that you would run. For the flexibility with different flow cells, users are able to run anywhere between 16 and 384 samples on the current Dplex MIC-TB assay. Our goal is to empower scientists to answer their questions with proven performance and global expertise. As a proven technology with over 360,000 publications, Illumina performs 3,300 trainings globally every year with over 900 support personnel, but the most pride comes from our customer feedback and the surveys with 97% satisfaction. But we don't always get it right, and we're not all perfect. During COVID, we ran into challenges as borders and countries shut down. Where it makes sense today, we strive for distribution or direct channels in country, because borders do shut down and it's hard to get people into country. But if the people are already there in country, regardless of a pandemic, it's easier to get support that you need. With these changes, Illumina has made an increase in accessibility and support. If we look at the global map, Illumina Global operates in all of the orange and blue territories. So there are direct and indirect channels. Our distributors or our channel partners are direct reflection of Illumina as they're trained and educated on our products at every launch and continuously throughout the flow. There are a few countries, though, that where we have a few exceptions. North Korea, Syria, Iran, and Cuba are all under embargo. And then more recently, with the uncertainty in the West, there are sanctions over Russia and parts of the Ukraine. So globally, where we do not sell direct, we have over 160 partners serving over 120 countries. Regardless of the sales and support channels, Illumina provides support through every step. Our comprehensive support organization, the expansive peer network, and even innovation collaborations through our programs like the Illumina Accelerator Program to drive new applications, advancements in technologies, and provide funding for startup companies. The most exciting piece, though, that I find is the global health access initiatives, where we've really tried to make things more accessible on the ground, especially in low and middle income countries. So the Global Health Access Initiative is an evolution of the Illumina's effort during the COVID pandemic to address challenges in enabling access, specifically in these regions, with hopes to create equitability or equitable access and pricing. The initiative is now expanded to include consumables for a range of applications, including broad viral surveillance, respiratory pathogen characterization, a custom amplicon library prep solution for addressing what could be a local pathogen in your country's interest, and most importantly for this call, culture-free detection and prediction of drug resistance and tuberculosis. The idea here is to provide a single part number from one vendor at an equitable price. If you're interested, I've provided the link below for more information. So just to summarize, together, Genoscreen and Illumina provide the best-in-class assay and technology solutions with global access and support to fight drug-resistant tuberculosis and advance the World Health Organization strategy to end TB. And with that, I will end it and say thank you.
Thank you so much to Kelly and Nelly and our presentations on the Genoscreen and Illumina platform and assay. We really appreciate it. We'll proceed now to our second presentation, which is from Oxford Nanopore, the manufacturer of the Nanopore TB assay. Christian Corns is the global health lead in TB diagnostics at Oxford Nanopore. Christian's, over to you.
Thank you. Can you hear me well?
Yes.
Great.
Thanks.
So I will share my screen. I will try to share my screen.
I think we can already see your screen. Great. Thanks.
Yes, great. Thank you. So thank you very much. So yes, my name is Christian Corns. I'm the global health lead at Diagnostics, which is Oxford Nanopore Diagnostics company, which is the smaller part of the Oxford Nanopore Technologies. We are focused on the clinical applications of our technology. And first of all, I'd like to thank, of course, Stop TB Partnership and FIND for this opportunity. I think it's very important to give this airtime and exposure to a wider community for the industry. So without further ado, please allow me to introduce our technology. So I will try to walk you through the Nanopore technology, the Nanopore TB test itself, and the partnership with bioMérieux, which means how do we plan to market and to commercialize the product. Just a couple of slides on our technology. So we have one core technology, which is the Nanopore technology. And the Nanopore technology is scaled up and built into different flow cells. So you have a fungal flow cell for smaller throughputs. You have the MinION, which is the more popular probably, and the PromethION flow cell. And then obviously these flow cells are then built into the instruments. For the sake of the clinical application, we will focus more on the MinION flow cell and the GridION instrument. The GridION instrument, which has the computer on board to facilitate the data analysis. So the technology is made of some key elements. The key element is the flow cell, as I mentioned. The nanopores are built in or built into the flow cells, and then the motor enzyme, which is then attached to each nanopore. And then obviously you have some chemistry, and combining all of these conditions allow us to detect and allow us to flow the strains through the nanopore and really read, interpret the results. So the DNA or RNA is attached to the motor enzyme, to the motor enzyme, to the nanopore, and then it is passed through at a speed of approximately 400 base pairs per second. And the electrical signal that is being created by the strains passing through the nanopore is turned into the so-called base calls. And this is how we can also ensure a real-time sequencing. So if you're interested more into the technology, obviously you can go online. There's a lot of information online, but I thought it would be important to give you a quick overview of our technology for those who haven't seen it before. So further on, I'd like to focus on the Nanopore TB test, which we developed based on the Oxford Nanopore technology. So we do have a 6-hour sample to result test. Within those 6 hours, we do have 2 hours of sequencing. We do screen 16 TB drugs with one integrated solution. And in technically how it looks, basically you have, it is a reflex test, important, it's a reflex test to TB positive samples. The specimen type is sputum, and sputum to result in 6 hours, as I mentioned. We propose automated or manual extraction protocols. We do detect more than 1,200 drug resistance associated mutations, 60 drug resistance targets based on 27 amplicons, and the kit will contain 96 vials, but effectively you will be able to run 88 samples, which will be sequenced in 4 batches. So each batch will contain 22 samples, and each batch will also contain 2 controls. As I mentioned, you have a part of the technology is also the flow cell. The flow cell will be reusable and washable. And the workflow, the high-level overview of the workflow basically looks like you decontaminate the cells, you do the DNA extraction, you do the multiplex PCR, then you prepare your library. It takes you approximately 3 to 4 hours, and then the sequencing is done, followed by reporting and analysis, and it all takes approximately time. As I mentioned, so we propose 2 extraction protocols. One is the automated extraction, one is the manual extraction. This is all described in the IFU. So once it's available, you'll be able to get yourself introduced to it. So on the antimicrobial resistance profile, so we do detect the 16 drugs and pretty much all the drugs that are used to a lesser or wider extent in TB treatment. The first line drugs like rifampicin, isoniazid, ethambutol, pyrazinamide, and the second line drugs. And here I think it's important to note that a little bit echo on Anita's presentation that we didn't have included in the recommendations, in the recent recommendations, drugs like bedaquiline and clofazimine for one reason. So when we developed the test, we based it on the first version of the WHO catalog. And we did have the wet lab already prepared for all the drugs, but the analysis pipeline included only the drugs that were in the WHO catalog version 1. So once the version 2 came out, we were able to include those into the software or build in or include in the analysis pipeline. And this allowed us to significantly, and we're happy really to see that results dramatically improved for key drugs today that are being used in the BPL regimen. So we do really hope that soon we'll be able to see also publicly more data on that and also see more of that included in the WHO recommendations. So here's an overview of the 4 uses of the flow cell. So as I mentioned, you have 4 batches run on the single flow cell. So the kit will comprise, the kit will have the vials in it, the flow cell, and the wash kit that you will have to wash the flow cells between the runs. And then you will use them up. So I think here's also one note on from our side. Sometimes the flow cell is considered as a consumable. Now we would like to have the flow cells back for 2 reasons. Basically, it is the environmental impact, because we can refurbish them and recycle them, and you would have less waste. So this is something that I'd like to also raise publicly. So I was thinking to include this slide or not, but I think it's very important. Since there's a lot of excitement about tNGS technology in general, whether it's Ampore or whether it's Oxford Nanopore or other, but something sometimes gets either silenced or not really spoken out loud. The thing is that the technology currently still is limited to certain infrastructure, environment, training levels, and so on. It means that you cannot really deploy it to the point of care level. And really what I want to show with this slide is that through the process of sequencing, so you have the decontamination, extraction, PCR barcoding, and sequencing, you do need additional items for this to perform the test. And it means, you know, it can be infrastructure like cold storage. It needs some more equipment, and it also needs some specific training. So I think this is very important, that to understand that even if we want to introduce this technology into our national programs, we still have some limitations, or we need to take in account the necessities which are around implementation. So then I'd like to show you a couple of slides on the result interpretation. So we have the AmPORE-TB built into the GridION, the AmPORE-TB software, which will not require any cloud upload. So you will not need any internet connection. So all the data is sitting on the instrument, and the automated execution after the sequencing will be presented to you on the screen. So I will just zoom into this part where you see the results. So the results will be reflected in such a form. So you will see the red ones, which will be called out as a resistant, and the blue-gray ones, which will stay the same if no resistance is detected. And also you will be able to see more in the details, species and oligotypes, and just a quick overview. You will have the possibility to see the SNP calls, and also the insertions and deletions. And like I mentioned, these are all referred to WHO mutation catalog. And with the second version, we were able to improve the performance. So on overall, the main advantages in this technology is the sample to result time to result is 6 hours, 16 TB drugs screened. A very important point is that this instrument is maintenance free. So the only thing that you basically do is you replace the flow cells, which is then if you want, a consumable, but the instrument itself is maintenance free. It is easy to implement. It is deployable in diverse environments, and it has a very small footprint. So if you're familiar with a GeneXpert instrument, then you have approximately the same footprint as the GeneXpert instrument. And then I would like to finalize the presentation with our go-to-market strategy, and how do we want to ensure that this technology really reaches the customers in need and the patients in need as fast as possible. And maybe you have heard or not, in April last year, we stepped into a partnership with a company called bioMérieux on several projects. And among those several projects, there was also the commercialization and the distribution of AmPORE-TB test. So bioMérieux's partnerships, they are pretty well known globally for antimicrobial resistance presence in this arena, and through other partnerships like private programs and memberships and sponsorships, we do see that the AmPORE-TB is an addition to their portfolio, and this is why we can really go global with the product and with this partnership. So bioMérieux is presented internationally in 160 countries, and they serve 45 countries are with subsidiaries, and pretty much covered. The globe is pretty much covered with a network. So the network in all the countries, either subsidiaries or distributors, and effectively. The distribution channels, how do we plan to do it, and how it's in the strategy. So we will be transferring all the product to bioMérieux, all the products, and then bioMérieux will distribute them through subsidiaries, to distributors if there's no subsidiaries in the respective countries, and then also through the full procurement mechanisms. So we are closely working with the global health let's say, department of bioMérieux, where we are working together with platforms like the GDF, like PFSTM and the VAMBO platform, where we want to ensure that also the countries that have agreements with these platforms would be capable to have access to the product as soon as possible. The RUO version of the product will be available in September, and we do think, and we're intensively working towards also having included the product in the full procurement mechanisms by the end of the year. So by the TB Union, I hope that we would be ready to have access also through these platforms. So with this, I'd like to thank you for your attention, and over back to the moderators. Thank you very much.
Thanks so much, Christian. This was very concrete, very clear, and very helpful. And just to say that there are a lot of questions coming in, and the team behind the scenes, every speaker is doing their best to respond. So we'll try to do it during the webinar, but there is also an intention to answer all the questions even after the webinar, and Wayne is going to give some more details on that. We'll proceed now to our third presentation, which is from the Shengting Medical Technology Company, the manufacturer of the TB-seq assay. Dr. Hongkang Gu is the Chief Scientist at Shengting Hong Kong. Over to you. Thank you.
Hello, everyone. Can you see my screen? And this?
Yes,
Hello?
go ahead.
Oh, okay. Yeah. Okay. Thank you, Wayne, for inviting me to join the seminar. And it's really my honor to present what we have did in last 2-3 years here at the Hangzhou Shengting Biotech. And today I'm going to talk about the application of a Nanopore-based targeted sequencing we call TB-seq for the diagnosis of drug-resistant tuberculosis in China. So here I'm going to use the 2 or 3 slides just to give you a brief view of in the much of my time talk about the TB, the targeted next generation sequencing for detection TB and the other pathogens associated with the TB. And in the last section, I will present the study we have participated in last 2-3 years. Okay, so basically the Hangzhou Shengting Medical, we are headquartered in Hangzhou, Zhejiang province, and we also have 6 satellite labs in around China. You can see from the map, and also we provide a clinical test service. We have IVD R&D center and GMP also for medical regions like the TB-seq, and also we have provide scientific service, scientific research service for the university and the research lab here in China. Basically, most of our business in China right now. Hopefully, we can go through the WHO platform, can go to overseas for the business. So currently, we are dominating the TB commercial TB test market in China. We have a 2/3 of market share for the clinical test. And also we have a strong presence in the tNGS pathogen testing, with about 15% market share in China. We also have the market share for NGS oncology testing in China. So from this slide, you can see that from 1990 to now, the TB, both the deaths and incidence dropped dramatically. And I should thank the World Bank provided financing support for the initial 10 to 20 years, and also the WHO for guiding this guiding the TB cure. So you can see that in the 2025, the project, the deaths dropped like from 160,000 in 1990 to 2020 around like 20,000. It's a dramatic drop. Also the incidence, and it's like we project in the 2030, it's 35 cases. But the government hope even less incidence. So from this map, you can see the China, the incidence across China are quite different. Like some provinces like Xinjiang and Guizhou, this more incidence and the death rate compared with the East Coast, because the economy from here is much advanced compared with that the Xinjiang and Guizhou province. And also, it's very unfortunately now in China, it's about 7.9% of new cases in China with mild TB and drug resistance. 20% of previous treated TB cases in China, it's with multiple drug resistance. It's far above global average 3.3 for the new TB case, and 18% for previous treated case. This is very unfortunate. And also the China, because as I showed you in the first slide, we have a dramatically drop for the case, but still we have close to 1 million new TB patients in 2019. So for the TB test that we developed here, and this schematic how we developed the test. Basically, our test is the American sequencing based test, and we use the primer focus on the 16 gene and the ATS1 and ATS2 region for detect and identify bacteria and fungi. And also we use a specific primer for drug-resistant gene mutation test. As you will see, our product is somewhat kind of different with previous two manufacturer. And we are not only tested this drug-resistant gene, we also try to identify the potential infection with other pathogens like non-TB and other fungi, the bacteria. So for our test, we have from DNA extraction and multiplex PCR, library preparation, sequencing analysis. The whole process takes about 12 hours. And we also set up our automation library construction workstation in the headquarters in Hangzhou now here. And we can make a 96 library at a time. And we also have a TB web app for data interpretation. So here for our initial test, we call the TB-seq Ultra 1.0. The initial version can identify MTB and 168 non-TB, and we can detect as other products like 16 first line and second line TB drug, and also 6 NTB drug resistant gene mutation as well. And recently we just updated our TB-seq Ultra 1.0 to 3.0, and we include the additional 126 microbial that potentially cause co-infection with the TB, and also we include the one human gene, because this gene, according to literature, had been reported associated with this dosage usage for this TB drug. We also added more drug-resistant gene mutation recommended by the WHO last year. I should say for the sequencing platform, we mainly use this Oxford Nanopore, and we are trying to optimize and develop the test using Illumina and MGI, because there's a regional cost issue. We think about maybe have some advantage in the future. So here is our clinical report form, and we first report that if this pathogen is is positive or negative for the TB, and we also provide the sequencing read here. And if there's a positive, we report the mutation we found it, and that there's a mutation read. If they have a non-TB drug-resistant gene, we also list in our clinical report as well. And here is as I said, the Ultra 3.0, we included the result from other 126 pathogens that have been reported co-effect with TB. So in the last two, 3 years, we have tested 80,000 patients in China. And of the 80,000 TB tests, most were respiratory sample, and the positive read you can see from here is kind of higher, because it's most of our customer, our patient, and it's designated hospital. It's called Chest Hospital, so the positive read is high. And we also test a variety of sample across China. So here is the summary of this the drug resistance we test for the 80,000 people. You can see here we found that around more than 12% of multiple drug resistance for the TB, and also we have for the 20% of rifampin resistance. This is a kind of common, and also we have the less common is aminoglycoside is just less than 1%. So also our test is able to identify new variants. And here is one example. We found that the positive for RFP positive, and we found that the duplication for TTC, and we use a sample sequence to verify the result. So in the last section of my talk, I just show you the study we have participated in last 2-3 years. So here is one of the study, and we collaborate with a hospital in Hangzhou, and in this one we collect 160 sample from TB, suspected TB patient. We compare the TB test with the export, which is a common test performed here in China. And you can see the sensitivity for export is close to 63%, and the specificity is 97.9%. But the TB, the sensitivity much higher compared with the export. This is one of the study, the main finding. And also we have collaborated with another hospital in Guangxi province. For that one, we compare with this TB-seq with export the test conducted in the hospital. And you can see the specificity and the sensitivity compared with the TB-seq. The TB-seq is much better. And also, I should say, export can only detect one drug-resistant gene, but for one drug. But for our TB-seq, we found that we can test more drug, and the sensitivity and specificity is quite good. So in the last study of my talk, it's this unpublished result, and we have recruit like 1,200 TB patients. And by the way, the test is led by the Beijing Chest Hospital, and also joined by 5 other domestic tuberculosis hospital. And for the sequencing part, they just send it to our company here in Hangzhou or satellite lab. And we perform the TB-seq test and the hospital and do the culture assay or export assay, and also the TB qPCR and the AFP smear test. You can see this TB-seq outperform the other tests as well. This is a direct comparison, the export and the TB-seq and sensitivity is high, and the sensitivity, specificity, positive prediction value, and the negative prediction value is much significantly higher than the export. And also for the drug resistance, you can see here the consensus of TB-seq with this phenotype drug susceptibility testing assay. It's very, very high as well. So also we have for the results, so the the TB-seq can predict the drug resistance. You can see here that the data is really amazing here at most of above 90% of sensitivity and close to 95% or higher, some even 99.5%. So and with that, I'm going to stop here for the product information. Please visit us at www.shengting.com, medical.com, and all contact us, but info.shengtinggroup.com. Thank you very much. I'm hand the talk to the moderator now.
Thank you so much, Hong Kang, for your great presentation. And thank you to all of our speakers. We are lucky that we have a little bit of time available for Q&A, despite some really excellent presentations. I believe, Kelly, you had one question that you were going to respond to directly, and then we've got a couple that Smilka and I will ask out to each of the participants as well. So we'll pause there for the first answer from Kelly before we dive into some of the other questions. Thanks.
Hey, Sarah. I don't see a question directly, so if you...
Oh, forgive me. Perhaps it was maybe you were typing the answer, so I think we can just go to the full questions right now then, if that's all right with everyone. Smilka, is it all right with you if I start? Okay, great. So based on the questions that we're seeing, firstly, I think there is significant interest in targeted next generation sequencing solutions, but a lot of open questions as well. One that I think would be really helpful for everyone to address is around turnaround time. And then a lot of questions like the actual turnaround time, let's say from start to really when you get your readout. Sometimes we talk about it being 24 to 48 hours, but that isn't always practically true in a lab setting. So it would be great to start with that, and then I think we've got some other ones around cost that we'd like to see from the participants as well, but we'll pause there on turnaround time. Thanks. Over.
Yeah, so Sarah, I'm happy to address the first question. So as far as the assay goes, we give guidance on extraction methods. The Genoscreen team has done extraction through various pieces, and there's protocols in our user guide for that. But starting from the extracted DNA and going through library prep, sequencing, I think we outlined in there 24 to 48 hours. The variability there can be based on what's going on in the lab. If you have an 8-hour workday, people are able to load the sequencers and let them run overnight, and then analyze the data within an hour the next day. So it's a pretty straightforward process. Nelly, did you want to add anything?
No, this was very clear. Yes, thank you.
I can maybe add something from. Oh, there's an echo. I can maybe add something from the Oxford Nanopore or Ampor TB perspective. So the workflow effectively takes 6 hours time, but of course it will depend also if you have the samples enough samples ready to run, right? If we batch them in 22 samples per run, obviously you can run one sample as well, but it will be then, you know, less cost effective as you know, to run a fully batched run. But then from the extraction, as I showed on the screen, so you know, within 6 hours or 7 hours, you have the results if you have allocated personnel for that, if you don't have any breaks between, and so on. But the workflow is as it is.
Okay, great. Hong Kang, did you want to comment on turnaround time?
Yeah, sure. And for
Thanks.
us, and we performing daily based tests for last 2-3 years, and we can processing like 24 sample within 20 hours. Actually, we perform far more than that per day because we have multiple lab. And once we do the real test, you know, here in China, once the sample arrive the lab, we start processing, and we have for two shifts to work to make the library and the sequencing. And our test is about 20 hours. Because our patient require the report within the 24 hours, so we get the processing 20 hours and they send the digital report to the physician and the patient.
Perfect. Thank you so much, everyone. And Kelly, I think I found the question that it indicated anyway in the Q&A that you might answer live. It was around the physical pretreatment of sputum samples and using a bead beater and grinding bead. And if that is necessary, in fact, or not, or as it appears to be an unusual equipment for standard labs.
Yeah, and I apologies if I indicated I would answer that live.
That's
But
okay.
that being said, I'll defer to Nelly, who's been doing a lot of the R&D work on the extraction side of that.
Yeah, thank you, Kelly. Yeah, it depends on the extraction methods. I mean, there is no perfect answer. The very important concept is that you need to have MTB specific extraction methods. So such, for example, as the QIAGEN, QIAMP kits, the Maxwell kits, they're all already evaluated on MTB extraction. So this is really important to have an extraction method that is validated with mycobacteria.
With that, you don't need bead.
And so if there is no bead beating in the process, you do not need to add one.
Wonderful. Thanks for clarifying that from the Genoscreen side. We've gotten some questions on cost, and I think that I know that perhaps intentionally was not mentioned in any of the presentations, but if there's anything the three manufacturers can share both on instrumentation costs, so buying of the new platforms, and then also on reagents and cost of runs. Anything to that effect, I think, would be really helpful for participants. I know that some of that probably is still in process, but we're all quite curious. So I'll hand it to you, Christians, first, just to change.
Thank you.
Teams.
Thanks. So yes, as it stands today, I cannot call out a number of a cost, but what I can say is, because we have, like I said, we have the partnership with bioMérieux, and there's a lot of moving elements involved in this chain. So when we're talking about the cost per test, we are following, as a Northern Star, we're following the target product profile issued a couple of years ago by the WHO. And, you know, for those who have seen this, it's around, I think, $50 or $60 per test. So we are following that. I do hope that we might be, you know, on a better state to provide a better pricing. But it's very important here to note that the cost of the test will depend also if you run the batches full scale, meaning if you have the full samples. If you have the lesser samples for one batch, then obviously the cost will rise, right? And also from Oxford Nanopore perspective, you will have the initial capital expense, which is the instrument, which will you need to place, and again, it is within the target product profile, and we do hope that we will reach a better price. But you know, we have a meeting with some global health stakeholders in a couple of weeks, and we will discuss this as well with them. Over.
So Sarah, I guess I'm happy to provide more guidance from the Illumina Genoscreen partnership and our combo assay. So currently, list price in the United States is $85 a sample. Though through our equitable access program, we've included a bundle of the sequencing reagents as well. So all in library prep, the amplification using the dplex MIC-TB assay, and sequencing on the platform for about $100 a sample. And that was the guidance that we had seen from WHO originally, with all-in pricing of $100, not just the library prep portion.
Thank you.
So for here at Shengting China, we have that price is
Glad to know I'm not the only one with technical difficulties.
oh yeah. Okay. Let me see. Okay. So
There.
we because we perform a routine test for patient, and we calculate the label reagent. So, but we do not have, like Illumina and Oxford Nanopore, they have a sequencer. We have to buy either currently the sequencer from Oxford Nanopore, and then hopefully in the future from Illumina.
Thank you, Hong Kong. We might want to follow up on that just and get it because it was a little bit broken in terms of the connection. So either you might want to just repeat, or we can also add it to the notes from the call. It didn't come across clearly. Sorry. Can you just repeat on the cost?
Yeah, sure. And here in Shengting Medical, we perform daily based clinical tests, and we calculate the reagent and the label roughly about $80 per sample per case.
Thank you. Thanks.
Yeah.
Thanks for that. Can I just before we shift the pricing, and it's linked also to a question in the we have kind of focused on a lot on the price of or on a kind of fixed price for reagents. I guess one of the questions that the countries will have, although we've seen the increase in sequencing capacity due to COVID, but not necessarily the sequencing capacity corresponds to the needs of the country for the TB sequencing. So countries will need also platforms as well. What is the thinking about making these available? Are there any considerations across industry to look into different placement modalities for these? So that's one question. And the second one is that understandably, there are some, there were a lot of questions around the cost, and I hope that over the next 1 year or so, we will be generating also some operational kind of costs from the field, so that we see the true cost. But to what extent, as the volumes grow, will companies also take that into consideration for future price reductions and kind of improving the affordability of the test? So volume-based pricing and placement considerations across the three companies, please. Thank you.
I guess I'm happy to jump in there. Okay, so through the equitable, the Global Health Access Initiative, and somebody asked a question about that in the chat, so I sent the link through there to the website. There is also special pricing on instrumentation. So we didn't go into the details around that. As you mentioned, there's access to systems all over the place at this point in time, but there is also special pricing. I don't remember off the top of my head exact pricing on those particular systems specifically for low and middle income countries to try and improve accessibility. I'm trying to think, did I answer all of your questions? So exactly, instrument pricing, special pricing is available through the Global Health Access Initiative.
Placement strategies and volume-based pricing.
So volume-based pricing is already taken into consideration in that Global Health Access pricing, but I think there is consideration in talking with the Illumina about any further discounting from there, but that was already taken into consideration in the price model.
Okay, thank you. Christian, do you want to jump in?
Yes. So one thing I must say is that Oxford Nanopore and the product Nanopore TB is very young in the market. So what we are currently focusing on is actually how to really use bioMérieux as a vehicle and distribution network, and to get to provide access to the technology in the many countries. But having the experience also from other technologies, this is something that we absolutely want to discuss with you. Discuss with organizations like United, USAID, and others. Once we start to scale up, obviously we can discuss the volume-based approach and specific placement strategies, but we haven't addressed them yet because it's just very, very early in our journey.
Thank you.
I think for this question, I have less to say because we do not manufacture any sequencing platform here at Shengting Medical. Sorry.
No worries. Understood. Thank you. Sarah, did you want to cover any other question from the? You're mute.
Thank you, Svelka. We are very close to ending, but I think we can probably ask maybe one more question. I'm just trying to see, Svelka, if there's anything burning on your end from the Q&A. We can certainly go that route. There are some questions around RUO versus IVD that might be helpful in terms of just that everything is currently RUO if it's available on the market, including a lot of the Illumina platforms that are currently sitting in countries as well that maybe were purchased during COVID, and then obviously O&D, some of your platforms were also distributed during COVID, but as well as for the assays, which obviously will be available RUO initially, but I think folks, that makes it more difficult for some countries to purchase. So we'll pass it over. Thanks.
Yeah, so Illumina has access and sells both RUO and DX platforms. Specifically on the MySeq platform, we have a CE labeled product for that instrument, as well as Genoscreen sells directly the CE IVD labeled current version of their dplex MICTB assay. So both flavors are available currently from Illumina in RUO and CE IVD marked.
Thanks.
Sorry.
Go on, Christian. Sorry.
No, just to say, so yes, obviously our test is the first version will be RUO version. We are also in parallel, obviously, going through the IVD route and FDA route as well. So we do hope that working with the full procurement mechanisms, it will also facilitate a little bit the access to the technology to some countries for the RUO product. But the regulatory approaches are as they are, and we do need clinical trials, which we are initiating. So the timelines are difficult, from today we are targeting end of 2025 the IVDR, but again it will depend on the clinical trials, and you know there are usually hurdles and challenges.
Yeah, here our story a little bit different because we in China have, as I saw, have a lot for TB patient, and we have done the test for last 2-3 years, and also the government also ask us to register, and to hopefully we can start our clinical trial very soon, end of this year. But by the way, first we have to start the clinical here in China first, and then we maybe can try that other market like Southeast Asia and also Africa.
Great. And then there was just one more question that I think it would be important to address in the time we have left, more of a clarification, in fact. And this is for Genoscreen. Someone asked what the estimated timeline for the Dplex XL was up into the WHO recommendation, as it will be first of on class, which will test for PA. I will hand that over to you, but I wanted to make sure we have the clarification that only a few protominid targets are included, and we really do not currently have a good understanding of all the relevant variants for protominid yet. So I don't think we would classify this as a truly sensitive test for protominid, but I will allow the experts from Genoscreen to provide that clarification. Thanks.
Thank you. So this is a good question, and we are currently discussing the modalities to have this recommendation. So this is in discussion with FIND. So yeah. So for the moment, we do not have a precise timeline, but of course, this is something ongoing.
Great. And to clarify on the protominid, these are just some initial targets that we know are relevant among multiple variants, which will be included as they become identified. Great. Smilka, I'll pass it over to you if you have any other burning questions. Otherwise, I know we're running over, and we can certainly answer remaining questions via email.
Absolutely. And I think that was, thanks, Sarah. I think we've touched upon everything. I am seeing Christian, for example, answering some of the questions about the availability for purchase, etc. So as you said, we'll make sure that all the questions have been answered and we will share this together with the presentation as well as the recording of the webinar. And stay tuned for the next one. There is one more coming, at least one more on this exciting topic, and we will be glad to reconnect very soon and continue this conversation. Thanks a lot to Wayne and the team at Stop TB Partnership also for coordinating us all and making this possible, and of course FIND industry partners, USAID, and all the participants and questions that were so many. Thank you.
Thank you so much to everyone.
Thank you.
Thank you.
Really appreciate it.
Thank you.
Excited in the interest.
Thank you.
Thank you.
Bye-bye, everyone.
Bye.